Here I'm going to describe how to use nonlinear regression to analyze kinetic data using the POLYMATH program, and particularly using POLYMATH because it's a relatively easy to use program to carry out this regression. So the model that we're looking at is fitting kinetic data to this rate expression, and we're determining these kinetic parameters. And this is explained in more detail in another screencast. What I want to do here is show how we actually get the results, particularly these results for the values of the parameters and their confidence limits, using the POLYMATH program. So let's look at the actual program and start from scratch and input the data to see how we can utilize POLYMATH to very quickly carry out this nonlinear regression. So I've opened the POLYMATH program, and then I'm going to go to Program and select Regression. And we're going to do nonlinear regression. So on the right side here, select nonlinear regression. And first I need to put data into the system, into the program. And this is very similar to a spreadsheet. So I've actually typed the data into Excel spreadsheet, and what I'm going to do is just copy the data to save time. And now I need to actually label. So this first column is rate, so let's just call it R. It actually corresponds to the negative of the rate of reaction of A, so it's a positive number. The second column is the concentration of A, so if I click on the column heading, I can change the label. So it's concentration of A, and then I can click on the next column heading and the concentration of B. So these are data that I want to fit to a model. I've selected the nonlinear regression, so in the section I'm going to type in the model. And the model is going to be that the rate is a rate constant multiplied by the concentration of A raised to some power, I'll call it N, and then multiplied by the concentration of B, also raised to some power that I will call M. So then POLYMATH automatically identifies the parameters and asks for initial guesses. So I'm going to enter in initial guesses of 1 for each of these values. And it's important, if we're too far off in initial guesses, the program's not going to converge, but these turned out to be good values for converging. The dependent variable it shows as R. The independent variables are concentrations of A and B. If I hit the purple arrow, then it's going to do the calculation. It's going to carry out the nonlinear regression. I want the output to be a report, so that's checked. A graph, so I'll check that. The residuals, so we get an idea of if the fit is random, if the error, is random. And also store model, which will put into a column the calculated values, so that if we want to do more calculations, very much like a spreadsheet type calculation. So when I select the purple arrow, it carries out the calculations. The report shows me the value of K and the values for N, slightly greater than 1, and for M, slightly less than 0.5. Also gives confidence, 95% confidence intervals. It gives the R squared value, it gives variance, and then it shows the values calculated, the measured values. In the third column, the calculated values, and then the difference, the residual. It also shows a plot, and let's expand this a bit. This is plotting the residuals, the difference between the experimental value and the calculated value as a function of the rate. And then this is showing a fit to the data to show for each point how close we are compared to the experimental data, how close the model is. And you'll notice we have a fourth column now, and it shows it's the calculation. So we can call this R calculated. So you can see very quickly we can calculate the parameters to fit data using POLYMATH, and very easy program to use, takes very little time to actually implement a nonlinear regression.